So here we're going to talk about combining functions and all the different ways we can combine functions. And as you can see, we're going to add, subtract, multiply, divide, and do composition. So if you missed the composition of functions video, you can go check that out on my YouTube channel. So I've got a couple of functions, f of x and g of x. And f of x is 3x minus 17. G of x is x plus 10. If you're taking notes, now would be a great time to pause and get some stuff written down. And then we'll get into it. So for f plus g of x, what this is saying over here is we're just going to add the f and g functions together. That's all that's telling us to do. So it's really combining like terms. So 3x minus 17 plus g of x, which is x plus 10. We combine like terms. We've got 3x plus x, that's 4x. Minus 17 plus 10 would be minus 7. And that's what f plus g simplifies down to, is 4x minus 7. So for subtracting, it's really the same idea. We're going to take f of x minus g of x. So this one here, f minus g, and then parentheses x, that's just telling us subtract the two functions. So we've got 3x minus 17, and then minus g of x, which is x plus 10. Now I'm going to be careful. When I subtract these functions, I need to make sure that I put the one in parentheses, because all of this stuff is getting subtracted. So the negative applies to both things inside the parentheses. So we got 3x minus x is 2x, and then negative 17 minus 10 is minus 27. All right, the next one, that circle, is f times g. And so we're just multiplying these two functions together. We've got 3x minus 17 times x plus 10. And then if you remember, multiplying binomials is what this is called, is we're going to distribute each thing in twice. Sometimes teachers call it foiling. Sometimes you'll see like a box method. If you're familiar with that, I'll kind of draw it off on the side. You'll write like 3x minus 17 on the top and x plus 10. This is called an area model, where you find the area of each one of those rectangles in there. You could also just distribute. So 3x times x and 3x times 10. So this ends up being 3x squared plus 30x. And then we can also we have to distribute the negative 17 into both of them as well. So we get minus 17x minus 170. And then what we do is we've got some like terms here. We end up with our final answer being 3x squared plus 13x minus 170. So that is f times g of x. Now typically when you're doing arithmetic, anything where you're dealing with adding, subtracting, multiplying, dividing, usually dividing is the hardest one. It ends up being complicated. There's a lot of steps involved. In this one, it's actually pretty easy. It's almost dumb. It's so easy. So we do f divided by g. All we write is 3x minus 17 over the g function, which is x plus 10. And that's it. If you can simplify anything, if there's common factors in top and bottom, you cross those out or reduce it, I guess. But that's it. You just take the one divided by the other. Now, you do need to give the domain restrictions, and what that means is if there's anything that causes dividing by 0 or negative square roots, we got to list that. And so in this case, x cannot equal negative 10. So that's kind of what we have to do for dividing. So I guess dividing does have one kind of trick to it. But you just have to say, you put the one function divided by the other function, and then you just state whatever makes the bottom of that fraction 0. So if x is negative 10, we end up dividing by 0, which is a no-no. Okay, and then just a reminder on composition of functions. Once again, if you didn't check that out, you should probably check that out before you watch this. But This fog here represents f of g of x, and so I typically will write it like that. And that tells me I'm going to write down my f function, which is 3 times x minus 17. And then I plug in g of x in where x used to be. So it would be x plus 10. And then we're just going to distribute the 3 in. Scroll down a little bit. And we get 3x plus 30 minus 17. Then if we combine like terms, we end up with 3x plus 13. And so that would be f of g of x. You could also do g of f of x, and you'd probably get something different. In fact, you would get something different. All right, and so that is looking at, if I give you two functions, you know, f of g of x, f of x and g of x, then you can combine those. But what if you're given like a table or a graph, and they say combine these functions here? So in this table, let's try to kind of do 3 examples just to understand what's going on in this table. So the x values are up above. Let's kind of put a little box around those. And so when this one says f of 0, that means I go to where x is 0, and I look, what is f? And f is 2. So f of 0 is 2. If it asks me what's g of 3, I go to 3. I go to the g function, and that is also 2. They happen to be the same. What about f of 4? Let's do some erasing here to clean stuff up a little bit. There we go. So f of 4, that means I'm going to go to 4. Look at the f function, and that is 1. Okay, so this next question asks me, what's f of 2 plus g of 1? Let me see if I can do this without making a mess. F of 2 plus g of 1. So f of 2 is 6. G of 1 is 3. That's 6 plus 3, which is 9. What about f of 5? We'll do this one in white. F of 5 is 3 minus g of 6. G of 6 is 4. So we got 3 minus 4, which is negative 1. What about f of g of 1? So once again, this is f of g of 1. Well, g of 1 is just a number. So if I look on this graph, we'll do this in red. G of 1 is 3. So this is really saying, give me f of 3, because g of 1 is 3. Well, f of 3 happens to be 0. So f of g of 1 is 0. All right, if you feel like you're getting it, I would encourage you to pause it now and try the last one and see if you can get this one without my help. I'm going to kind of clean the board here so we have a clean slate for this last example. All right, so g of f of 7. I'm going to write this one out. Do this in orange. G of f of 7. So let's go to f of 7. F of 7 is 7. So this is telling me to do g of 7. So then I go to g. G of 7 is 6. So the answer to that is just 6. So those are a couple different ways. If you were given a graph, you would just go, you know, if we graph this thing, f of x at 1 would be 4. So that graph would be 1, 4. And then it'd be 2, 6, and then 3, 0, and then 4, 1. So that would give you all the points on the graph. So you do it kind of the same way. You would look on the graph, where is the y value at the given x? So anyway, there's a couple different ways of looking at combining functions.